Welcome to our YouTube channel. We want to continue with our area of coverage, that is nitrogen and its compounds. Previously, we have covered laboratory preparation of ammonia. Now we want to cover industrial process now to manufacture ammonia gas in large scale. The process known as the Haber process. The process known as Haber process. Haber process. So Haber process is an industrial process which is being used to manufacture ammonia in large scale. So for us to manufacture ammonia, we have raw materials that we are supposed to be studying. So one of the raw materials that we have, one, we have nitrogen. Number two, we have hydrogen. These raw materials, it's important that we know their sources. Where do we obtain them from? Nitrogen, we obtain it from fractional distillation of liquefied air. Well, hydrogen, we obtain it from cracking of alkanes, of long-chain alkanes, where we remember that we have two cracking. We have catalytic cracking and thermal cracking. So we obtain hydrogen from cracking of long-chain alkanes. So the two gases, that is nitrogen gas, hydrogen gas, are mixed in the ratio of 1 to 3. Are mixed in the ratio of 1 to 3. It means 1 volume of nitrogen is reacted with 1 volume with 3 volumes of hydrogen to produce for us the ammonia gas. So I'm going to bring for you the flowchart for us to describe how these two gases are being manufactured. So we can see how the two gases can be used to manufacture ammonia gas in our flowchart that is going to be displayed for us. So we want to see how those gases are being manufactured from the flowchart that we are going to see. Now, we are seeing from our flowchart, that the two gases are, we are seeing from our flowchart, the two gases are being reacted in the ratio of 1 to 3. And the first one is nitrogen, which we have already discussed as being obtained from the fractional distillation of liquefied air. Then another one is hydrogen, being obtained from cracking of long-chain alkanes. So the two gases are first purified, and the reason why we purify these gases is to remove impurities. The impurities are unwanted substances which may poison the catalyst. So one of the impurities include carbon 4 oxide, sulfur 4 oxide, and dust particles. They are being removed by the process of electrostatic precipitation. They're being removed by the process of electrostatic precipitation because they can otherwise poison the catalyst. Once the impurities have been removed, the two gases are then compressed to about 400 atmosphere. And the role of the compressor is to raise high temperature is to raise high pressure, which is required for the ammonia synthesis. Once the gases have been compressed, we pass them to the heat exchanger. Why do we pass the two gases in the heat exchanger? The heat exchanger will play place of about 3 roles. One of the roles of the heat exchanger is to preheat the gases, for preheating of the gases so as to attain high temperature for the gases to react. Another one, it maintains high temperature for the two reacting gases. And then the last one, it is where the cooling of unreacted gases takes place. It is where the cooling of unreacted gases take place. We are going to realize that the gases which has not reacted in the heat chamber are being preheated back in the heat exchanger so that to allow them to attain a good or optimum temperature for them to react. Then from after the catalytic chamber, the gases are being passed, after the heat exchanger, the gases are being passed to the catalytic chamber. When the catalytic chamber, ammonia gas is going to be formed. When nitrogen reacts with hydrogen in the ratio of 1 to 3, we are going to form ammonia gas. We're going to form ammonia gas. So in the catalytic chamber there, we are going to see from our, in the equation that I'm going to write, that it is where the ammonia gas is going to be formed when nitrogen is reacted with hydrogen in the presence of a catalyst known as finely divided ion catalyst. So we use finely divided ion catalyst to speed up the rate of reaction. So the role of that catalyst, the finely divided ion catalyst, is to speed up the rate of reaction, leading to the more production, more yield of ammonia gas in the system. Then unreacted gases, which might have not reacted in the catalytic chamber, are being passed back to the heat exchanger for cooling. Then once the gases have been passed through catalytic chamber, the ammonia gas will be formed. So the ammonia gas formed is then passed to the condenser, where it is going to be liquefied. After it has been condensed, it is going to be liquefied. Then once it has been liquefied, we are going to form our liquid ammonia. We're going to form our liquid ammonia. So I have mentioned that that is as far as the industrial process of Haber process is concerned. The most important thing that a student should know here are the raw materials. Then you should also know the role of the purifier and what are substances being purified. We call them the impurities. You need to alert those impurities as stated. So that is as far as how Haber process is concerned. Now we are seeing the flowchart on how the gas is being manufactured. We have seen the flowchart on how the gas is being manufactured. So for the equation for the reaction, let us follow up the equation for the reaction here. We have nitrogen gas reacting with hydrogen gas in the presence of a catalyst known as a finely divided ion catalyst. So I'll ask you, why do we use finely divided ion catalyst, but not just ion catalyst? Finely divided ion catalyst. We are going to form our ammonia gas. We're going to form our ammonia gas. So the equation must be balanced for the reaction to take place, for the reaction to be complete. So we have gases here. So this is the equation for the reaction that lead to the formation of ammonia gas, and it is from the Haber process. So I want to display for you some few questions after this so that we discuss. But before that, what The ammonia gas formed has got very many uses. The ammonia gas formed here has got very many uses after it's been passed through the condenser where dilution takes place. Once it has been diluted to form ammonia solution, which has got wide uses. One, it is used in the manufacture of fertilizer. Number two, it is used in softening of water. Then finally, it is used in the removal of greasy stains from nylons. So those are at least one or two uses of ammonia. So I want to bring a set of questions so that we see which type of questions you can be asked in a given industrial process when you're told to discuss areas dealing with what? Other process. So other process is just an industrial process which is being used in manufacturing of what? Ammonia. Know the role of each and every step, like the heat exchanger, know the role of the catalytic chamber, know the role of the condenser, know the role of the compressor, and know the role of the purifier, and know the raw materials. So I want to display the question for you so that we discuss with you in a short while. Otherwise, let me invite another speaker to bring for us questions under ammonia gas. So we are bringing 3 questions in our next class so that we discuss more on question answer approach on how we can answer questions dealing with the HABA process. Thank you.